significant figures. So, a measurement can only be as accurate and precise as the instrument that produces it, or produced it. A scientist must be able to express the accuracy of a number, not just its numerical value. We can determine the accuracy of a number by the number of significant figures it contains. So there's a few rules with determining the number of significant figures and numbers. The first one, all digits 1 through 9 inclusive are significant. So any non-zero digit is significant. So for the first example here, 129 has 3 significant figures or digits. Number 2, zeros between significant digits or non-zero digits are always significant. So an example, 5007 has 4 significant figures, or you'll hear me say sig figs. Number 3, trailing zeros in a number are significant only if the number contains a decimal point. Example, we have 100.1. That has 4 significant figures. That decimal point and is an indicator that those non-zero digits are significant. And they would also be significant no matter what, because the zeros are in between non-zero digits. Now 100 only has 1 significant figure because there's no decimal point after that last zero, so just that 1 is the only significant figure there. Number 4, zeros in the beginning of a number whose function is to place the decimal, act as a placeholder, are not significant. So 0.0025 only has 2 significant figures. That 0.00 only acts as placeholders. So now to check, to understand how many significant figures you have, you can go ahead and put this number in scientific notation. So 1, 2, 3, we have 2.5 times 10 to the negative third, and we see we only have 2 significant figures, as we do here. Okay, and the last rule here is zeros following a decimal significant figure are significant. So if we look here at 0.000470, it has 3 significant figures. So I'll explain this a little bit here. These 3 zeros are just there for place value, so they are not significant. Our 4 and our 7, definitely significant. But this last 0, this is where this rule applies. Zeros following a decimal significant figure are significant. So this makes it 0 significant. So there's 3 sig figs. Now here, right, anything zeros after the decimal point, after your non-zero digit. So we see here 1, 2, 3, 4, 5. So 0.47000 has 5 significant figures. So just a few other practice problems here. Say we had 0.02. Right, this 0 just acts as a place value, so we have 1 significant figure here. 501, we have our 2 significant figures, 5 and the 1, and this 0 is in between 2 non-zero digits, so that makes that 0 significant, so we have 3 here. And then same thing here with 10,001, these 3 zeros are in between non-zero digits, so that makes these 0 significant. So we have a total of 5 significant figures here. Okay, so now there's a couple other rules here. First one is for addition and subtraction with significant figures. So when adding and subtracting, limit and round your answer to the least number of decimal places in any of the numbers that make up your answer. So for example, we'll have 2 of them here. We look here, I look at 123.25. There's 2 decimal values here, so 2 here. 46.0, there's 1 decimal value here. 86.257, there's 3 here. So in our final answer, we should only have one decimal value, excuse me. So we have 255.507. So since our least amount of decimal values is 1, we should only have 1 in our answer. So that should make 255.507, our final answer, be 255.5 sorry about that, milliliters, right? 1 decimal value. Just a little. There we go. Perfect. Now, if we want to do another one, 55.46 minus 28.9, I see I have two decimal values here, and I have 1 here. So my final answer should have 1 decimal value. So if I did this out, 55.46 minus 28.9, and I get 26.560. But I only want 1 decimal value. So this, I'm looking at this 5. Since this is greater than 5, I could round up. So my final answer would be 26.6 grams. Okay, so that's addition and subtraction. Now multiplication and division. So when multiplying and dividing, limit and round to the least number of significant figures in any of the factors. So addition and subtraction dealt with the least amount of decimal point values or place values. Multiplication, division deal with the least amount of significant figures in your numbers. So if I look at this first example here, I have 23.0, so I have 3 significant figures here. 432, 3 significant figures. 19, I have 2. So my final answer should only have 2 significant figures in it. So I look at 188,784. I should only have 2 significant figures here. So my final answer should be 190,000 centimeters cubed. Okay, now 1.35 meters has 3 sig figs, and 2.467 meters has 4 sig figs. So my final answer is going to have 3 sig figs. So if I multiply these, I have 1.35 times 2.467 and I should get 3.33 meters cubed. And this concludes our video on significant figures.